All right, good morning, everyone. Glad to be here. I mean, this is definitely one of the not very nice place to have the conference, so glad to be part of the program. What I'm going to present today is one of the study that we recently completed for NRA, the National Road Research Alliance, and it is related to the use of high RAP materials and how to deal with Rejuvenator. Before I get started, just like to share some background information. As we all know, like the use of RAP, provides significant economic and environmental benefits. But at the same time, asphalt mixtures containing high RAP content, could have durability issues because those binders are very stiff, brittle, do not have good relaxation properties. Over the year, there has been increasing interest in using rejuvenators, which is kind of like chemical-based additive that can rejuvenate the rheological and in some cases, chemical property of the asphalt binder. If we look at what has been done in the past, the two major factors that affects, how well the rejuvenator work includes the two factors listed here. One is the viscosity reducing capacity and the chemical composition, which is more related to the material quality. There are so many different products on the market and they do not provide the same benefits. And the other factor that has been recognized but not heavily investigated, at least from the research perspective, is the degree of dispersion and diffusion. As I mentioned before, Rejuvenator is trying to rejuvenate the heavily aged asphalt binder, make sure we got the uniform dispersion and the diffusion, and therefore the blending of those two components is significant. Currently, there are two rejuvenator application methods. The first one is called like a pre-blending method, which means like we pre-blend those chemical additive into the virgin asphalt binder. The other approach that has been investigated in some part of the world is called like a pre-treatment. In that case, we are adding those rejuvenator into the wrap instead of the asphalt binder. By doing that, it provides opportunity to directly interact with the rejuvenator and the heavily aged binder in those wrap. So the difference between the two approach here is, one is related to, targeting binder quality, and the other one is trying to target the wrap quality. Both matters, but the question is which one is going to be more effective. So the study that we did here, the objective was try to further enhance the rejuvenating effectiveness of these two approaches. So in terms of motivation, what we did was to leverage the foaming technology for the pre-blending method. So in this case, we're still adding the rejuvenator into the virgin binder, but then like we do the mechanical foaming so that we can create the volume expansion and increase the surface area. That way that it can provide better dispersion and diffusion once upon contact with those two materials. For the pre-treating method, we use a similar approach, also leveraging the mechanical foaming, but in this case, we foam the rejuvenator instead of foam the asphalt binder. I mean, the same concept that Starbucks has been using to foam like the coffee latte, right? Like you got the milk, you foam it, creates the volume expansion and surface area. That's what we try to do. And also, in addition to the foaming, we also look into the emulsification because of the emulsification process. We increase the volume of those chemical additive and therefore provide the potential for better interaction. With that being said, the objective is really to explore those three alternative methods of adding rejuvenators. And the most important question we try to understand is to determine their impact on the cracking resistance of the high RAP mixtures. That's kind of like the end goal. So those are the key points that we need to make sure those mixtures are going to perform in the field. In terms of research approach, what we did was kind of like 4 steps as shown here. On the very left side is what we call like rejuvenator characterization. This is the surface tension and viscosity of the rejuvenator itself to help us to better understand the surface characteristics of those material so that we can do modification if needed to provide a better foaming behavior. After that, we look into the foaming experiment. This is where we try to optimize the different foaming conditions. We look into the temperature, water content, and the pressure, try to maximize not only just the foaming volume expansion, but also the stability of that foam material. And then after that, we look into wrap pretreatment, marination, and mixture performance testing. For the sake of time for this presentation, what I'm going to focus on is the last 2 sections that highlights there. So in terms of the wrap pretreatment and marination, the objective was to determine the impact of these two processes on the wrap quality characteristics. We use a very heavily aged wrap from the southeast part of the country, and then we look into like a 3 pretreatment method. One is the spray on, foaming, and emulsification. And after that, we did the marination evaluation, looking to 2 very different marination conditions. One is called like elevated temperature, hoping that the high temperature will accelerate the diffusion of those rejuvenator into the wrap. But then the other approach we look into is called like extended marination, which means like does not involve heating. So we just let time to do the job. So, try to look into which one going to work better if there's a difference. In terms of evaluation, we look at downgrade workability, look at the durability evaluation, and also we look into the grayscale-based image analysis, which I'll provide a little bit more information. And also we did binder extraction to look into the rheological and chemical composition of those asphalt binders. In terms of image analysis, it's very straightforward. As you can see here, it's a regular desktop printer that we all use in the office or at home. And then we put a layer of recycled asphalt pavement on top. We get the image shown in the middle, and then we apply some data analysis to look into the grayscale distribution. So there are 2 things that this image or this distribution tell us. One is kind of like the grayscale numbers. Is that going to be on the light side or on the dark side? And that tells us how much of those asphalt binder is activated. And the other parameter that we look into that is the weight of the distribution plot that indicates the consistency of this material. As we know, like in some cases, wrap can be pretty variable. So that's another variable that is important. Based on those test results we found out that pre-treating wrap with rejuvenator, no matter which application method we look at, significantly improve the wrap quality, which is not surprising to us. Among the different pre-treatment methods, the emulsification approach worked a little bit better than the other 2 approaches investigated in the study. When we look into the marination, we did not find that has a significant impact on the wrap quality characteristics. But when we look into the extracted binder testing, we found an interesting observation that marination provides a battle between rejuvenation and the aging. If we, as I mentioned before, higher temperature going to accelerate the diffusion. That is something we want. But at the same time, high temperature could cause further aging of the asphalt binder. So if it's pretty much like if you do low temperature, the diffusion may take a long time. But if you do high temperature, diffusion would be faster, but aging could have a detrimental impact. So this is something that we'll look into in the future to try to balance out these 2 fighting mechanisms, if you will. And then in terms of performance testing, we look at 2 high wrap mix designs. As you can see on the screen, one is 45% wrap, the other 50% wrap. So that's almost double the amount of average wrap content in asphalt mixtures in the United States. So that's definitely considered a kind of like aggressive, wrap mix design. We look at 5 mixes for performance comparison purposes. The first one is the control, which means there's no rejuvenator. So this is kind of like the standard mix, if you will. And then all the other 4 mixes have a rejuvenator, but the differences are how the rejuvenator was added. Some were pre-blended into the virgin binder with or without foaming. The other 2 use like a rejuvenator to pre-treat wrap. One using foam rejuvenator, the other using emulsified rejuvenator. And then in terms of testing, what we focused on was workability and the cracking resistance. When we talk about the cracking testing for asphalt mixtures, asphalt aging play a significant role. That's why we consider long-term aging for that evaluation. For the sake of time, what I decided to present here is just kind of like example set of data, try to illustrate kind of like the concept or the trend that we seen from the study. This is ideal CT, which is an intermediate cracking test that has been looked into by the research community. Pretty much in this plot, a higher number indicated better cracking resistance. But my personal experience with that, like there might be some limitation with these tests when we look into different additives, but for Rejuvenator, overall it worked pretty well. But anyway, based on the results we collected, we found that adding rejuvenators in general improved the workability and the cracking resistance of the mixes. That's why you see like, the 4 bars on the right side give us a higher numbers as compared to the control, which is, promising, that indicates the rejuvenator is doing the job, right? That's what we want. And then when we focus on the comparison of different application methods, interestingly, we found that pre-blending methods provide better results as compared to the wrap pretreatment method, which is something I did not expect personally, because I was thinking like the pretreatment is going to provide a better option because of direct interaction. And then we have a hypothesis that can explain this, and this is something we try to look into in another NCHRP project that we recently got. But based on what we found out here, the pre-blending method worked a little better than the pre-treatment. And for the 2 pre-blending method, the one using foaming technology provide a better workability, which is not surprising to us. This is something we expected because of the volume expansion and the surface area expansion that provide a better coating and therefore better diffusion. But in terms of the cracking resistance, foaming is pretty much an instantaneous benefit, if you will. So it just really provide a prolonged cracking resistant improvement, and that's what we saw here. So based on these results, we provide a recommendation to the industry that to continue to use a pre-blending method to add rejuvenators for high wrap mixes for 2 reasons. One is on the performance side, we saw better performance. That's what we want. And the other side is more on the practical side, is easier operation. For those of you who have experience operating asphalt plant or working in the asphalt plant, you know how much easier to add those rejuvenator using the inline blending than try to pre-treat the wrap. Unless you have some specialty, batch plant that give you more flexibility to deal with that perspective. For those plant that already equipped with foaming device, it's actually a pretty good practice to use foaming technology. First of all, it provides better workability and have a potential to improve compaction in the field, which is always a plus. And also it allows us to look into the possibility of reduced production temperatures. As the asphalt industry move into the net zero, try to kind of like reduce the carbon emissions. This is one of the most effective approach, not the most effective, one of the effective approaches to achieve that. So that's kind of like why we provide that recommendation, to kill 2 birds with 1 stone type of deal. And also we try to look into the DWT as a quick test for assessing the quality and consistency of the wrap stockpile, which is a big deal for the industry moving forward. Finally, I want to make acknowledgement to the team. I got the opportunity to be here to present, but those are the team working on the project, including the former graduate students and some other researchers working on the team. The study was sponsored by Minnesota Department of Transportation, so NRA, and also we have industry sponsor of the study that provide cost share. So appreciate their funding support of the study. With that, thank you very much for your time and attention, and that is my contact information. That project has been completed, so we do have lots more information to share for those of you who are interested. I don't know how much time we had, but if there's any question, I'll be glad to take them. Thank you.
Thank you, Dr. I think we have time because I just got more next speakers on the level. Oh. So we have time for questions and probably questions for the previous 2 sessions as well.
Yes, Robert.
Yeah, thanks, man. Great presentation. I think the pre-blending, it's kind of surprised us that this is the best approach, but I think it's consistently what we're seeing. But when you pre-blend, now you're kind of affecting the grade of your virgin binder, right? I mean, essentially now you're just lowering the grade of your virgin. It's almost like softening, right?
Yeah.
So from that perspective, did you guys try as a comparison any very soft grain virgin binders, like a 52 minus 34 or something instead of 58 minus 28?
Yeah, I mean, that's a good question. We did not look into that option. I know that is considered one of the practice out there. It's using softer binder to accommodate a higher wrap content. But for this study, I mean, the scope is kind of like, try to focus on different ways of adding rejuvenator. To be honest, I think, balanced mix design provide the opportunity for the contractors to engineer, to innovate, whether or not using softer binder or using rejuvenator, they need to consider, the economics, the performance, and the environmental. So, I say both approaches could work, which one to decide, it's really a mixed design question, but we did not look into that in this study, but we have some other study, we look into the softer binder.
So,
Ms. Doctor.
very intriguing presentation. One thing I was curious about is the whole concept of wrap, right? So nowadays there's a lot more unconventional asphalt binder being used, say warm mix or bio asphalt or polymer modified or nano engineered binder. So another 20 years down the road, when we look at the wrap, I'm sure they'll behave quite different. The recyclability of these unconventional binders. I just want your insight on that.
Yeah, that's a question that we started to look into now more and more because of kind of like, the sustainability, focus of our community. I think at this point, agencies, at least from the asphalt application perspective, agencies have not thought about the recyclability of those material as they get further aged. Personally, I think there will be a limit to the stiffness or the rheological property of the wrap. To beyond that point, we really need to deal with that material a little bit differently than what we are doing right now. I know we have some speaker from Japan over there. They do have requirement on the extracted binder. So if the penetration is lower than threshold number, they're saying like you cannot use them as wrap in asphalt mixtures. If you want, you can use it at aggregate because you still have those 95% of the solid particles. But how to make sure like we are using those material responsibly is something we need to deal with. So, but that's a great question, Dr.
Actually, a related concern is not all the wraps are the same.
Oh.
So if a wrap has gone to Minnesota 20 years later, probably.
Oh, we get a bird here.
New audience. Quite a bit salt combination or whatnot, versus Florida, a lot more UV aging. So wood filtration test alone probably won't tell the full story. Again, the quality control, quality assurance or acceptance test of the wrap seems to be recyclable.
Yeah, absolutely. 100% agree. Right now, the way agencies accept wrap is based on binder content and gradation. But as we all know from the research perspective, the binder quality matters. So that's why like when you talk about oxidation versus UV radiation and also what kind of base binder you start with, I think that is a missing kind of like a knowledge gap that need to be addressed. I think moving forward, we do need to better understand the wrap binder quality. In addition, just to look at how much binder is there volume wise, because both binder quality and binder quantity matter. In terms of the asphalt mixture performance, if that makes sense. Thank you very much. All right, thank you.